Hey there, this is Adeep from T Technology. In this video we are going to talk about the most important concept of software testing, which is principle of software testing. Let me open my document. So principle of software testing, principle is nothing, is a fundamental guidelines. It helps testers to test software under test effective, efficient, and reliable. So while creating test cases, we need to use some strategy and execute test cases in a manner that as a tester we maximize the quality assurance of that software under test. So these principles, these guidelines are universally accepted. So what is the purpose of these principles? It ensures that software under test is of high quality, meet the both functional and non-functional requirement. So when I say functional, means the behavior of the application. Non-functional is the performance of the application. We might have a separate video lesson on them. So let's start to know more about these guidelines. There are 7 principles of software testing. So in these principles, what I did, I put explanation for each principles and implication for each principles. You will learn the definition of them, and then you know from testing point how we can apply them in a testing strategies. These 7 principles are very key important key concept for the software testing as a beginners. So let's start. Number 1, testing shows the presence of defect, not their absence. If you want to explain this one, is what does it mean? It means testing can prove that a defect or a bug is present in the software under test. Even though this software under test or application pass all test levels, but still there might be some hidden defect which is uncovered by the test. It means it can never prove the defect is absent. There is always a defect in the application. So how we can apply this concept in the testing? So testing cannot guarantee that the software under test is completely free of defects. We never say as a tester, oh, this application is tested, there is no bug. We cannot say this one. But it is important to focus on detection of the defect rather than the perfection. We cannot prove that this software under test is perfect, but we can focus to find the defect. In here is not the matter of perfection, how much perfection is the application. In here is the matter how we can find technically, analytically, paying attention to details to find a defect in the application or software under test. Let's move on to number 2, early testing. or some people call it shift left testing. So what this principle means, this principle specifies, it explains that testing should start as early as possible. It means as soon as the requirement drafted, the documentation is provided, testing should begin. You can start testing by reviewing those requirements. So while reviewing those requirements, you might find some defects. So that defect is, fixing that defect is much cheaper than in later phases. So how we can imply this early testing concept in the testing process? Testing is a process that we can always prevent defect. So in the software development life cycle, SDLC, we will have a separate video on SDLC. So in here we need to start testing as soon as we got the requirement, by reviewing, analyzing, unit testing. Why? Because if that defect is in requirement, if that is not fixed, if it goes to the later phases, if it goes into production, if it goes to the end user, fixing that bug is much expensive than fixing in the requirement level. So that's why testing should be started as soon, as early as the requirement is drafted. Let's move on to the very interesting concept, which is principle number 3, defect clustering. This concept is also known as the Pareto principles, or also known as 80-20 rules. What does it mean? It means 80% of a defect often comes from 20% of the modules or a feature. For example, the whole application, and only you test about the feature, the login feature. If you find a defect in a login feature, which is the small module of the whole application, then remember 80% defect will come from this login feature. Why? Because this login feature is connected to access, password, to authorizations, security. So that's why this principle is very important. It says a small number of modules or feature typically contains the majority of defects in a system. So how we can imply this concept in testing? In testing, we should focus on the areas that are more likely contains defect, prioritize our testing strategies or on criticals, where is the high risk areas in application, and complex logic, then we should start testing on them. If the critical feature is the login and functionality, security, performance, then we should focus on the login access, data access. So defect clustering is talking all about, if you find a defect in a small module, then focus, pay attention on that feature, you will find more. Let's move on to the principle number 4, pesticide paradox. It's a very much people ask in interview these questions a lot. So in pesticide paradox, what does it means? Running the same test case over and over, it will not allow you to catch new defects. Or in other words, if you repeat the same test case to discover a new defect, it does not work at all. In interview, they ask you the question, how do you catch bugs, for example, in regression testing? So you can easily say, we update from implication point, we update our test cases based on new test scenarios, based on new techniques, based on the test environment, in order to identify or to catch new issues or new defects. So testing principle says we should regularly update our test cases, because running same test does not catch new issue. Remember this one. Always we need to upgrade our test cases in order to catch new issues. We will deep diving on while we are doing on testing methods. Number 5, testing is a context dependent. It's very important. For a tester who just started, it's very important. What does it mean? The method of testing, the approach of testing, a strategy of testing is must align to the type of software. If we are testing to the type of the software, type of the environment, to the context that we are using that software. For example, it says clearly, web application, testing of a web application is much different than mobile application. Or testing on a high performance complex system is much different than testing on a simple CRUD application. CRUD, which C stands for create, R stands for read, U stands for update, D stands for delete. Those applications that perform these 4 functionality: create, read, update, delete. Or in the UI, read, search, review the data. So this application much different than the high complex performance application. Testing is much different. So how we can apply this concept on the testing? For the testing strategy should always be adapted to the project specific needs, environment and constraints. It means our testing strategy should match what is our requirement, what is the project, what is constraint, what application, what software we are using. Based on that one, we start our testing strategy. It is a very high level and big concept. So I just bring here to remember, as a tester we need to know our software. Based on that software we can start design our testing strategy. Number 6 about absence of error is a fallacy. What it means, for example, the software under test is defect free. There is no defect at all, but it does not meet the requirement of the end user. It is still a failure. Yes, because it does not meet the requirement of the end user. it does not meet the expectation, it is a failure. How we can imply this concept in testing? In the testing, we should not only focus on defect, but also we should focus to ensure that our software meets the requirement, meets the specification, meets the business need, meets the end user. So always, defect is not just functionality is not working. Defect can be requirement is not right, it does not provide business value, it doesn't match to the specification, it's not reliable, it's not usable. They all consider as a failure. So we need to focus on them, not only on defects, but also about the to see user needs. It's very important to remember that testing is not always finding defect. Testing is also to see that application or software is meeting the user requirements or not. Principle number 7, exhaustive testing. And it was an interview question as well. Hey, can we do exhaustive testing? If tester knows this principle, he can easily say, no, exhaustive testing is impossible. Why? It's clear in explanation. It mentioned that we cannot test every possible combination of inputs, every paths, every scenario, every complexity of software system. We cannot configuration, we cannot test it. It might be because of the time, it might be because of the resource or testers that we don't have. It might be because of complexity of logic, so many other factors. So generally this principle says exhaustive testing is impossible. So then what is the solution? If you know then this principle, then you can easily answer the question of interviewers. Exhaustive testing is, do you do exhaustive testing? No. And instead of exhaustive testing, I'm focusing on the risk-based testing. Where the most critical high-risk areas are tested truly. When we say high-risk areas, then we can find some strategies, test techniques like boundary value analysis, equivalence partitioning, pairwise testing to optimize testing coverage. Those are the testing techniques that we use in order to see the functionality, to meet the functionality of that software under test. So these are 7 principles of software testing, which is very important for beginners. So I bring it in the picture because we need to remember them. If you got any question about any of them, please comment in below. I am trying to reach you out to reply to your questions. Thank you.